In this video, we'll be examining soil and water properties. In our experiments, we'll use sponges to simulate soil. Like soil, sponges have pore space. Some of these pores are macropores, and others are micropores. In this experiment, we'll place the end of a dry sponge into a beaker of water. What do you predict will happen? We see the water traveled up the sponge. This is because the pore spaces in the sponge are interconnected, creating something similar to capillary tubes. Capillary rise is greater in the micropores of the sponge than in the macropores. In soil, water can move upward due to the same capillary action in micropores. In this experiment, we'll see if the orientation of a saturated sponge will influence the amount of water dripping from it. The orientations or positions we'll try are flat, upright, and sideways. From which of these orientations do you predict will drip the most water? After saturating the sponge, we hold it in a flat orientation without squeezing it, catching all of the dripping water in an empty pan. The water dripping from the sponge is called gravitational water. This is the water that cannot be held by the macropores. However, water is still being held by the micropores. After the sponge quits dripping, we measure the water we collected. After saturating the sponge again, we hold it in the upright orientation. Without squeezing it, we catch all of the dripping water in an empty pan. After the sponge quits dripping, we measure the water we collected. After saturating the sponge once again, we hold it in the sideways orientation. Without squeezing it, we catch all of the dripping water in an empty pan. After the sponge quits dripping, we once again measure the water we collected. The orientation of the sponge affects the length of the connected pores. The water held in the upright orientation is more difficult to hold in the macropores of the sponge. Therefore, more gravitational water is released from it. In this experiment, we'll stack saturated sponges to see if the position of the sponge in the stack affects the water held. Once the gravitational water has dripped from the sponges, we'll squeeze out the water from each sponge in the stack. Which sponge do you predict will hold the most water? More water collects in the bottommost sponge. Gravity pulls the water downward through the stack of sponges. Some of this water drips out as gravitational water, but matric potential in the micropores holds on to some of the water. The same happens as water percolates through soil profiles.